In this online video, we are going to revise connecting particles by the help of two examples. But before example one, I want to talk about forces that occur in pairs. What I mean tension and thrust. If we have a trailer here and a car, if this is the directional movement and acceleration is in the same direction, if movement and acceleration is in the same direction, that means we have tension. And tension is always away from the object. It is away from the object. This is tension. When movement and acceleration is on the same has the same direction, that means we have tension on the tow bar, and tension is always away from the object. When we have a car here, not in good shape, and this is the trailer, this is the car. If car and trailer moves to the right, but acceleration is in the opposite direction, that means the system is going to stop. The brakes are on. The brakes are producing friction force for the system to stop. Then again we have a pair of forces on the tow bar. Again we call them T, but they are actually thrust. And thrust is always to the object. Not away, but to the object, points to the object. These are the differences between tension and thrust. So let's solve example 1. Let's redraw the graph for example 1. Here we have a trailer of mass 300 kilograms, and the reaction force, the force of friction, the reaction force on the trailer is 250 newtons. We have a tow bar here. The car of mass 1200 kilograms. The reaction force on the friction force on the car is 600 newtons, and there is a driving force of 1800 newtons there. So as you see, we don't have any brake force on the car. The movement is there to the right, and we have an acceleration to the right. So on the tow bar we have tension in pairs. First of all, the question is calculate the acceleration of the car and the trailer. So we are going to take them together as one object. We are going to take the car and the trailer as a single object. And what is the formula that we are going to use? We are going to use force is equal to mass times acceleration. And here, this is Newton's second rule. And how do we calculate net force here? Which is going to be equal to mass times acceleration. Here, net force is, the driving force is 1800 newtons. And the opposing forces are 250 and 600, which is equal to a total mass of 300 plus 1200 200 times the acceleration. So 950 is equal to 1,500 times A. So acceleration is equal to 950 divided by 1,500. This is 19 over 30 meters per second square. Let's carry on with the question. Now everything is going to change. Sorry about the story of the question. I don't have enough space there, so I revised the question for you. Now the driving force is 0. We don't have that 1,800 newtons there. Let's redraw the diagram, the shape for the question. The trailer, the car is there. Masses never changes in M1. Here we don't have, for the second case of the question, we don't have any driving force. Brakes applied. Brakes produce a force of F on the car. Still we have 600 newtons there as the reaction force, and we have an additional force F opposing the motion of the car. But the car is moving to the right, still moving to the right, and we have the opposing force of 250 newtons on the trailer as well. And the question says that we have thrust, and thrust always points the object. And here the thrust is 100 newtons. And the question says find the resistance to find the value of F. Before that, we have to find the acceleration, the new acceleration. To be able to find the new acceleration, I am going to use the trailer because it has less force. On the trailer we don't have any unknowns. We know all the forces acting on the trailer. So on trailer, F net is going to be mass times acceleration. What are the forces? Minus 150 opposing the motion, a thrust of 100 newtons which is also opposing the motion, times the acceleration, which is equal to mass times the acceleration. Minus 350 is equal to 300 times the acceleration, minus 350 over 300 is equal to acceleration. So new acceleration of the system is minus 7 over 6. Now let's work with the car. On car, again F net, sum of F forces must be equal to mass times acceleration. We have minus 600 there, acting on the opposite direction of motion. We have new force of friction occurs by the brakes. The mass is 1,200 times the acceleration. Here, minus 600 minus F is equal to times the acceleration. So minus 600 minus F is equal to minus 1,400. So force is equal to 800 newtons. The brake force is, this is direction of motion, but as you see, acceleration is in the opposite direction. It is a negative, it has a negative value. So instead of tension, we have thrust on car and on trailer. If you don't have any questions, I am going to send you the solutions. Now I am going to solve question 2 for you, which is again a connected particle question, but we have a pulley here. And on the pulley we have an inextensible string. So draw the graph for the question. Question 2. We have the pulley there. We have particle A of mass 6m. We have two particles here, 4m each as a mass. We have B and C. Because the mass of B and C together is greater than the mass of A, we are going to have such directional motion. So we have 8 mg there as the weight, tension pointing upwards. We have 6 mg there, tension pointing upwards. Because let's have two equations for A, B and C together. Here, this is the direction of motion, so F is equal to mass times acceleration. What is the net force here? 8 mg is pulling, the tension is greater than the tension, so 8 mg minus the tension is equal to the total mass, which is 8m times the acceleration. This is the first equation that we obtain from B and C together. Let's check the object A. Here T is in the direction of motion and 6 mg is opposing the motion. So Newton's second rule, force is equal to mass times acceleration. Here's net force is going to be tension minus 6 mg, because tension is in the direction of motion and 6 mg, the weight of A, is trying to oppose the motion. What is the total mass here? 6m times the acceleration. Now we have two unknowns, tension and acceleration, and we have two equations. So let's solve them simultaneously and solve for tension and acceleration. Minus T plus 8 mg is equal to 8 ma. Here tensions cancel each other. 2 mg is equal to 4, let's add them, 14 ma, m's cancel each other. So acceleration is g over 7, where g is the gravity, meters per second squared. Let's find the tension. Tension minus 6 mg is equal to 6m g over 7. So tension is equal to 54 over 7m plus 6, mg plus 6 mg. That makes 96 mg over 7. This is the tension on this ring. When A moves 0, this is the answer for part A of question 2. When A moves 0.8 meters, so system was at rest, acceleration turns out to be 9 over 7, and S is 0.8. Let's find the speed of A when it moves 0.8 meters above its original position. V squared is equal to U squared plus 2AS. This is a formula from kinematics. We already revised it. So V squared will be U squared plus 2 times 9.8, that is the acceleration there, times S, which is 0.8. So V squared becomes 2.24, take the square root, this is going to be 1.5. Yes, 1.5 meters per second. This is the answer for part B. Let's carry on with C. C separates and falls down. Now we have a different connecting particle system. Now A is moving up with a speed of 1.5 meters per second, moving up. B with mass 4 meters per second was moving down, again with the same speed because they are connected together. C falls down. Now we have only 2 objects here. So acceleration is going to change. A is going to try to pull B back. A tries to change the direction of motion, but because it has a greater mass now. But still, this is the direction of motion because the acceleration was g over 7 in that direction, in clockwise direction. So the acceleration is going to change. It is going to have a negative value, but still A moves up, B moves down because it has an initial speed from the previous condition. So here this is 4 mg, the weight, this is the tension. Again we have 6 mg there, the new tension, because we don't have C that anymore in the system. So T minus 6 mg is equal to 6m times the acceleration. Here we have a different equation because we don't have any C there. Let's write them and solve them simultaneously. At them, minus 2 mg is equal to 10 ma, m's cancel each other. So acceleration is minus g over 5. So A tries to stop the system and make the system turn in anti-clockwise direction. But before that, this is answer for part C. And find the greatest height reached by A. But again, A still moves up. So when C breaks, separates, the speed was 1.5 meters per second. Acceleration is minus g over 5, and it is going to stop somewhere, so velocity will be 0. And what will be the displacement? V squared is equal to u squared plus 2as, and 0 squared is equal to 1.5 squared plus 2 times minus g over 5s. So s is going to be 1.5 squared over 2 times 9.8, which is g over 5. So s will be by the help of a calculator, .3 meters. So total distance covered by A, the greatest height reached by A will be 0.8 plus 1.3, 2.1 meters, because A already traveled a distance of 0.8 meters before from its original position. This is the answer for question 2, and that's the end of the online lesson here for today. These are the 2 examples that I wrote down for you, and I solved it. Hopefully we are going to meet again. Bye from me. If you have any questions, I'm going to answer. Waiting for your questions and trying to send the pictures of the board to you. Yes.